Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math YouTube channel. If you're not already, go ahead and hit the subscribe button right now. Also, hit the like button. Like this video, okay? Also, drop a comment down below, especially if you have questions about anything that I'm about to describe in this here problem right here. Put your questions in the comment section too. Also, share this video with somebody, right? Somebody that's doing geometry, because we're about to get into finding the volume and the surface area of a cylinder, right? Now, I'm calling this glizzy math, right? Because it's about glizzies, right? Find the volume and the surface area of a typical size glizzy, because it's getting nice out. People are gonna start cooking out, barbecuing, and all that, right? Somebody might put some glizzies on the grill. You might want to eat a glizzy. You know what I'm saying? It's no shame. Hey, that's what you're into. It's cool, right? So yeah, so dig this. So a glizzy is a cylinder, right? It's a cylinder, right? So we gotta understand what a cylinder is, like a pipe, like a straw is a cylinder, right? I got an example right here. This is a straw, right? I don't have any actual hot dogs or glizzies in my kitchen right now, but this will do, right? Just for us to have an idea of what a cylinder looks like. So this is a cylinder, right? Now, when we find the volume, we're finding the amount of space that's inside this three-dimensional object, all right? In terms of cubes, how many cubes that would be 1 inch by 1 inch by 1 inch, right? Cubes could fit inside of a hot dog, right? Or inside of a glizzy, right? How many, right? That's what the volume tells us. Surface area is the amount of space on the outer surface or the outside of the glizzy, right? In terms of squares, right? Not three-dimensional, but two-dimensional, but squares, 1 inch by 1 inch squares. How many 1 inch by 1 inch squares could fit on the outside of a glizzy side to side with no space in between them? That's what we find when we're finding the area. It's a form of measurement, just like volume is. Volume is a form of measurement. The three-dimensional space inside of an object, in this case, a cylinder. Surface area is the space on the outside of the object. All right. Now, let's first start with some information. All right. Let's start with the formula. We got to know our formulas, right? When you're doing geometry, you're trying to figure things out, you're trying to find measurements, you need a formula, right? So the formula for the volume of a cylinder. Now, if you don't have these memorized, you should try to memorize them. All right. So the formula for the volume of a cylinder is pi r squared times the height. Pi r squared h. All right. Pi is something that we talk about on March 14th, Pi Day, because pi is equal to 3.14. Pi is a ratio between the circumference, which is the perimeter of a circle, any circle, divided by its diameter. The diameter is the length, or is a chord, but it's the length that goes across the circle from one end to the other and crosses through the center of the circle. That's what the diameter is. The diameter is an example of a chord. A chord is a line segment that goes from one side of a circle to another side of the circle, or one part of a circle to another. But a diameter is a chord that goes through the center. So the diameter cuts the circle in half. Just like imagine a pizza, right? It's circular. So if you slice that pizza down the middle, right, that's the diameter. You're also drawing the diameter of that pizza, right? Now, pi is 3.14. The circumference, the length around any circle divided by its diameter is always going to be 3.14. I think that's kind of fascinating. No matter how big the circle is, no matter how small the circle is, when you take the circumference and you divide it by its diameter, you always going to get the number 3.14. And 3.14 is an irrational number. It goes on and on and on and on. 3.14, 15926, and on and on and on and on and on. It never stops. All right. Now, R. R stands for radius. The diameter goes from one end of the circle all the way across to the other, and it cuts through the center. The radius goes from the edge of the circle to the center, right? So the radius is half of the diameter. The radius only goes from the edge to the center, edge to the center. Diameter goes from the edge all the way across through the center to the other side. So the diameter goes all the way across the circle. The radius goes halfway across the circle. The diameter goes all the way across the circle. The radius goes halfway across the circle, and it stops at the center. R stands for radius. So your radius is always, write this down if you don't already know it, the radius is half of the diameter. The radius is always half of the diameter. H stands for height. That's the height. So imagine, right? You got the cookout, we got the glizzy. It's like this, right? But in terms of height, imagine you turned it upright like this. The height would be the vertical length of it. All right. That's what the height would be. All right. In this case. All right. So now we're dealing with real life math. So every time you go to a cookout, you should be thinking about What's the volume of this? What's the volume of this I'm about to eat? What's the surface area of this, right? I'm trying to make it relevant, right? Because the math needs to be relevant. The geometry needs to be relevant. All right, that's what makes it easier. That's what makes it easier to do when it's relevant. All right, now surface area. What's the formula for surface area? We say SA for surface area. Surface area is 2 pi RH plus 2 pi R squared. I always like writing formulas down because when you write formulas down and people think you so intelligent because you got the formula memorized, it ain't even that deep. Plot twist, it ain't even that deep, right? Because you know why I know this? Because the surface area it's like this, right? Let me put this down real quick. So the circumference of any circle, right? Well, let me back up. A cylinder is just a bunch of circles stacked on top of each other. It's just a bunch of them, just a bunch of circles, right? A bunch of real thin circles stacked on top of each other. That's all a cylinder is, right? So if I want to know the surface area, what I do is let's say I find the circumference of one of them circles. Just one of them circles, right? The length around one of them circles, right? And then it's a bunch of them stacked on top of each other. And let's say in order for me to figure out how many it is stacked on top of each other, that would be equivalent to the height. That would be equivalent to the height. So let's say it was 50 of these circles stacked on top of each other. So that's like taking the circumference of one and multiplying it by 50. And that's going to give you the combined circumference, right? So the length around each of these circles, but it's a bunch of them stacked on top of each other. So that's why we multiply by the height, right? And then because 2 pi r is the formula for the circumference of a circle. 2 times pi times the radius. That part right there, C, which stands for circumference, equals 2 pi r. So you take the circumference of one of them circles, multiply by the height. The height is the actual like combining all the circles, right? That's stacked up on top of each other, right? And then why we add in 2 pi r squared? Because the cylinder has a bottom and a top, a bottom and a top. So the bottom is a circle, right? But notice, and the top is a circle. But dig this. When we did the 2 pi r, right, that was just the length around the circle, right? That wasn't like the surface area. That wasn't like the face of it. You know what I'm saying? And there's two of them. So you got a circle on top and a circle on the bottom. That's why we multiplying this by 2, because pi r squared is the formula for the area of any circle. Pi times r squared, just like over here. Pi times r squared times the height, right? Now volume, you know what I mean, of a cylinder is going to be the area, right? Then multiply by the height, right? That's how you find out how much is inside, right? Inside. All right. 2 pi r is just the length around, just the length around. But pi r squared is going to give you like the whole surface. That's going to give you the whole surface. So understand that the difference. 2 pi r is the length around, right? Pi r squared is the flat surface, right? So that's why these two are different, right? They're not the same. Pi r squared is not the same as 2 pi r. All right. But to find the surface area, you find the circumference of one of the circles, multiplied by the height, right? And that's going to give you all of this. That's going to give you all of this, right? That's going to give you the whole edge. And then you got to figure out, okay, well, what's the area of the top? The top, you find the area of the circle, right? Pi r squared. And then what's the area of the bottom, right? You do pi r squared again. All right. So it's two of them. That's why we do 2 times that, because they're the same. It's a cylinder. So the size at the top is going to be equivalent to the size at the bottom. So that's where the formulas come from. All right. Now, we need some information. We want to know the volume and the surface area of a typical size glizzy, right? So we need some information. Like we need to know what the radius of the glizzy is. We need to know the height of the glizzy, right? We need R and H. Pi we know. Pi we know is 3.14. All right. 2 we given. Exponent 2, exponent 2. So now I did a little research, right? The length of a standard typical hot dog is 4.8 inches. All right. Now the diameter of a typical glizzy is 1 inches. All right. So the length is 4.8 inches. The diameter is 1 inches. Now, for that information, we can figure out everything we need in order to answer these two questions. Figure out the volume and figure out the surface area, right? So now let me pause for a second because somebody might be saying, well, why I got to know this? How's this going to help me? Because this is an example of problem solving, right? We're practicing problem solving and we have problems, and we as human beings will encounter problems in life. And if we have problem solving skills, we'll be able to address these problems and solve these problems and eliminate them. If you don't have problem solving skills, your problems will maintain themselves and actually they will grow and exacerbate. That's a good word for you to look up if you don't already know it, right? The problems will exacerbate or grow exponentially. Exponent. The problems will grow exponentially. So when you're doing math, whether it's algebra, geometry, pre-calculus, trig, whatever, calculus, statistics, you're practicing problem solving skills, even if it don't seem like it. I know to a lot of us, especially young people, we never been adults before. We don't know what it's like out there in the real world when you're young, right? But you're practicing problem solving skills. And you'll notice that, oh, when you find yourself encountered by a problem, especially if the problem is more complex, you need to have a certain mindset and a certain method to be able to figure out how to first identify the problem and then proceed to solve the problem. So one of the things that geometry does, it gives you practice with solving problems. All right. So it's not just about the classroom. It's not just about geometry. It's not just about a standardized test or SAT or nothing like that. It ain't just about doing good in math so you can get a job, right? That's cool too, but it's about problem solving skills. All right. In case anybody was wondering. Now, I need the radius. If I know the diameter, what I tell you earlier, I told you, I said the radius is always half of the diameter. The radius is always half of the diameter. So what's half of one? Half of one is like half of a dollar is 50 cents. Half of one is 0.5. So the radius is 0.5 inches. All right. So now I'm about to find the volume real quick. So volume is equal to pi. Pi is 3.14. Memorize that. We're going to replace pi with 3.14. And again, pi is the ratio between the circumference of any circle. Circumference is the perimeter around the circle, right? Divided by its diameter. Diameter is the length, is a chord. It's the length from one end of the circle across to the other end, but it cuts through the center. It must cut through the center. If that chord don't cut through the center, it ain't a diameter. It's a chord, but it ain't a diameter. The diameter is a special chord that cuts through the center of the circle. So pi is 3.14. The radius of the glizzy is 0.5. So you got 0.5, right? Squared. Don't forget the exponent, right? And then the height, what does it say? The height is going to be the length. So, you know what I'm saying? Like the glizzy is like this, right? The length is 4.8 inches if you measured it. But imagine we turn it upright and then we measure the length, right? The length is 4.8 inches. So that's going to be our height, right? If we turn it upright, that would be our height. Our height and our length are synonymous in this situation. So we do 4.8 right there. Boom. Now we do the math. Now I'm gonna grab a calculator, right? But for some of this, I don't need a calculator because I know that following order of operations, which is something else we should all know how to do. I got a whole playlist on order of operations. All right. If we one of these people that think that you should always multiply before you divide, that's not correct. All right. Check out my playlist on order of operations. Please do yourself a favor. All right. Then we got 0.5 squared. 0.5 is the same thing as 1/2. So 0.5 squared is saying 0.5 times 0.5, which is the same thing as saying 1/2 times 1/2. What's 1/2 times 1/2? 1/4. What's 1/2 of 1/2? 1/4. Half of a half is a fourth or a quarter. So 0.5 squared is 0.25. 0.25. And you can verify it by putting it in your calculator or doing the manual math on paper. So now you got 3.14 times 0.25 times 4.8. Now I'm going to just multiply these three numbers together. Throw this in the calculator, 3.14. Or like sometimes your calculator, most scientific calculators have a pi button. You can either type 3.14 or you could just hit the pi button. Either way. You know what I'm saying? 6 and 1/2 dozen in the other. It's all good. So 3.14 times 0.25 times 4.8 is equal to 3.768. I'm going to round this off to one decimal place. I'm going to round it to 3.8 inches cubed, right? Where did this 8 come from? Because there was a 7 in the 10th place, but to the right of it was a 6, right? Because that's a 6 right there. If that number, this digit right here is 5 or greater, it's going to make the number to the left go up. It's going to make it go up. So this 7 going to turn into an 8. So 3.8 inches cubed. Why is it cubed? Because the volume measures the amount of cubes that could fit inside of that cylinder, side by side with no space in between, right? That's why the unit should always be to the third power if we're talking about volume. Talking about volume, we're talking about the third power. Volume to the third power, right? Because we're talking about a cube. That's why when we see something to the third power, we call it cubed. All right. How many cubes can fit inside that space? Whether it's a triangular prism, whether it's a rectangular prism, whether it's a cube, whether it's a cylinder. You know what I'm saying? As long as it's something three dimensional. If you find in the volume, the units must be cubed. All right. So 3.8 inches cubed. So that means that in a glizzy, 4.8 inches long with a diameter of 1 inches, we could fit 3.8, almost 4, 1 by 1 by 1 cubes inside of that. That's a way to measure the space inside of the glizzy. All right, now surface area. Let's go to surface area. Surface area, we got 2 times pi. Pi is still 3.14. That's not going to change, right? 2 times 3.14. What's the radius? Radius is still 0.5, right? What's the height? The height is still 4.8. All right, so 2 pi r h. 2 pi r h. Whenever you're doing a math problem, or especially whenever you're watching somebody do a math problem, when you're in class, make sure you understand everything that you're writing down. All right. Don't just be sitting in class just copying everything down with no idea what it means and no idea where the numbers came from. Don't be that person. And there's a lot of people that's like that. Please get into the habit of raising your hand and asking questions if you don't understand. Don't be scared to look dumb. All right, don't do that because you're gonna be lost. Like you need to know like where this 3.14 came from. It's pi. You need to know where this 0.5 came from. That's the radius. How do we know that? Because we know the diameter is 1 inches, and the radius is always half of whatever the diameter is. Because the radius goes from the edge of the circle to the center. The diameter goes from the edge of the circle through the center all the way to the other edge of the circle, right? So the radius goes halfway across the circle. The diameter goes all the way across the circle. So that's why the radius is always half of the diameter, always, right? And then the length, which is also the height. In this situation, the length is also the height. All right, it's going to be 4.8. Then you put your plus on. Then you write your 2. Then you put your pi again. Times pi. 2 pi means 2 times pi. When there's no symbol in between, there's no plus sign, minus sign, division sign, multiplication sign. In between the numbers or values, that means multiply. That's what that means. That means multiply. So you're going to do times 3.14. And the radius again is still 0.5 squared. Now this is just, you know what I'm saying? Just some basic calculations. Basic calculation. Oh, shout out to my man, Southside Slugger, Mr. T on Rocky number 3. Yeah, in case you was wondering who this is, this Mr. T off Rocky 3. Yeah, the Southside Slugger from Chicago. All right. So now we got, all right, I'm about to do this multiplication. We got 2 times 3.14 times 0.5 times 4.8. That's going to be 15.072. Put your plus sign. And then we're going to do the same thing. But look, follow order of operations. Use the exponent first. That's going to be 0.25, just like it was 0.25 up here. Because what's 0.5 times 0.5? What's a half of a half? Times means take of. The word of in math language means multiply. All right. So 0.5 times 0.5 is the same thing as saying what is 0.5 of 0.5? What is half of a half? Half of a half is a quarter. All right. Just like half of 50 cents is 25 cents. Half of 50 cents is a quarter. All right. So now we got 2 times 3.14 times 0.25. That's going to be 1.57. Then we're going to add these up. Bunch of decimals. So now we're going to have 1.5. I'm going to add it to the 15 on 5.072. Yo, man. 1.57. All right, here we go. 16.642. I'm going to round it off, just like I rounded this one off to 1 decimal place. I'm going to round this off to 16.6. Why 6? Because that's a 4 next to it. There's a 4 next to it. This number is not 5 or greater. If it was a 5, 6, 7, 8, or 9, excuse me, then the 6 would stay a 6, meaning you would go from 0.64 down to 0.60, right? When you round it, you got 2 choices. We want to round to the nearest tenth, so we're either going to go down to 0.6 or we're going to go up to 0.7. We only got 2 choices. The digit to the right determines where you go. You only got 2 choices. The digit to the right determines if you're going up or if you're going down. Because right now we at 0.64. So we can either go down to 0.60 or up to point 0.6, up to point 0.7, right? 0.7 no, technically. All right. But because this is a 4, we're going down to 0.6. So 16.6. And its area is squared because area measures the number of squares. 1 inch, in this case, 1 inch by 1 inch squares that could fit around the surface of the glizzy, right? You know what I'm saying? With no space in between, right? You know what I'm saying? Like that's what the area represents in any situation, whether it's you dealing with a circle, a three-dimensional object, a rectangle, a triangle, anything. So 16.6, and then we got inches squared. All right, so area is always squared. Volume is always cubed. Area is always squared. Volume is always cubed. All right, so yeah, that's how you use the volume. That's how you find the volume of a cylinder using this formula. That's how you find the surface area of a cylinder using this formula. All right, so yeah, just trying to keep it relevant. You know, it's math all around us. In our everyday life. You know what I'm saying? So, when you, like I said, when you at the cookout, you know what I'm saying? You get the glizzy, the you know what I'm saying, the glizzy off the grill. You know what I'm saying? Think about finding the volume, surface area of a cylinder because it is a cylinder. It's a cylinder basically. You know what I mean? All right, so make sure you're subscribed to the channel. If you didn't already hit the subscribe button, go ahead and hit the subscribe button. If you didn't like the video already, go ahead and like the video. Drop if you got a question about anything I did up here, please put your question in the comments. Please put your question in the comments. Or if you just got a comment about the video, you know what I'm saying? Something that sparks your interest or something that you know what I mean? Something you had on your mind. Put that in the comments. All right. And also share the video with somebody taking geometry or somebody that's gonna take geometry. Right? Share the video. All right. So again, my man, Southside Slugger. Yeah. All right. I'll see y'all on the next video. Peace.